The Milky Way could fit into the universe as we know it 10 million times. So it's big, really big. And we know that it's expanding at an exponential rate, which means that in about 1 billion years' time, the universe will be about 10% bigger. So do we know how big the universe is right now? And could we ever actually map out the size of the universe? So let's start with the bits of the universe that we can actually see. Light has a speed limit, so there's only so much of the universe that we can actually see, and we call it the observable universe. We think there are around about 170 billion galaxies in the entire observable universe. What we really need to work out how big the universe is a 3D map of it. That's what the Sloan Digital Sky Survey is trying to do. With 3 coordinates, you can make a 3D image of where to find all of the galaxies in the universe. By placing the plate with the galaxy coordinates over the telescope, they could isolate each galaxy individually and work out a 3rd coordinate for each one. That 3rd coordinate was redshift. And with redshift, the team could get the distance to each galaxy from the Milky Way. Dr. Slagle called it a 3D movie on a colossal scale. His team essentially brought the stuff of science fiction to life. Using this new map, cosmologists were able to see how galaxies were arranged in space.
Maybe you've seen things like this in the opening of Star Trek or Star Wars or whatever, and that all looks great, but it's not real. This movie, it is the real universe.
Just like our galaxy, the universe is held together by gravity, but there weren't enough galaxies to generate enough gravity to actually hold the universe together. Most of the stuff in the universe was missing. So this map led astronomers to some more evidence for something they'd been theorizing for quite a while now.
It's simply not enough stuff to arrange things into the patterns that we see, have galaxies spinning in the way that they do. There's something else there. There's something beyond the galaxies that we see, the visible matter.
It's called dark matter. It's invisible, and we haven't found a way of detecting it in a lab yet. I know it can seem like us astronomers just start making up wild theories when we don't understand maybe what's going on, but we do know dark matter is there, in the same way that we know the wind is there because we see the trees move. We have so much evidence for it, including the fact that the gravity it generates is literally holding the cosmos together.
What we're finding out there in the universe is really weird. It's equivalent to the idea that only 1 out of 6 cities in America actually has any people living in it.
There is 6 times more dark matter than there is in all of the stars and the dust in 170 billion galaxies in the entire observable universe. So does that mean that the universe is 6 times bigger? Well, no, not quite, but the universe is certainly 6 times heavier than we thought. And it's complicated by the fact that the universe isn't just full of invisible stuff that we can't see, but the stuff that we can see is also moving away from us. The universe is getting bigger, literally, as we sit here watching it.
It's an observational fact that if you look at the galaxies around us and the most distant galaxies that we can see, they all appear to be moving away from us. If you were standing in California, you would see New York moving away from you. But from the perspective of New York, you would see Boston move away.
By observing the brightness of supernova, Professor Saul Perlmutter and his team proved that the universe is not only expanding, but that its expansion is speeding up at an alarming rate.
At the end, we concluded that actually the universe really isn't slowing down. It's actually speeding up in its expansion. And that was a big shock.
Professor Perlmutter's discovery was so important to the scientific community that in 2012 he was awarded the Nobel Prize in Physics. So after you establish something like that, the question on everybody's minds is why?
Well, we don't know, but we did work out what to call it. We have a name for it. We call it dark energy.
And we figured out that the universe is about 68% dark energy.
The really crucial thing about how this dark energy behaves is that it doesn't dilute. When the universe doubles in size, you got twice as much dark energy. Make it 4 times as big, you've just got 4 times as much dark energy.
So how do you measure something that's big, that's getting bigger, that's full of stuff that we can't see? Well, unsurprisingly, you can't, or at least we can't yet. But what we have done is map out the stuff that we can see. And as usual, the universe has done things that we never expected it to do. And that map revealed that the universe is flat. Cosmologists plotted 3 points of a very big triangle that went from Earth to 2 points in space-time as far back as we could go.
If the universe were positively curved, if the angles inside the triangle added up to greater than 180 degrees, then it would be finite in size. If the spatial geometry is flat, if the angles inside the triangle add up to 180, then it could go on forever.
The answer was mind-blowing. Space itself is flat. Now, we're not talking about the shape of space here. We don't mean space is flat like a piece of paper. We're talking about how light behaves in space. For it to be flat, it means that light would travel on in an infinite direction and never be disturbed. If space wasn't flat, that light could loop back on itself. It'd almost be like if you could stare out for long enough and detect light faint enough, then you would be able to see the back of your own head.
That means that the simplest picture of the universe is a universe that's infinite. We really could live in a universe where there's galaxy after galaxy after galaxy in every direction, up, down, sideways, and it never stops.
This provided the perfect picture of what the universe looks like. An infinite universe filled with galaxies in all directions that is still getting bigger. Absolutely mind-boggling. But what we have done is map out the stuff that we can see. And as usual, the universe has done things that we never expected it to do. And that map revealed that the universe is flat.